Welcome back everyone, my name is Pedram and this is where we do advanced time series analysis, deep forecasting. Alright, module 2, setting up deep forecasting environment. So I'm going to do it in two parts. Part 1, basically I go over some basic slides, talk about different packages, setting up the environment. And in part 2, we're going to do things in Python. We're going to do some simple time series analysis in Python. All right, so this is the PDF, by the way. You can find it here if you go to my GitHub, deep forecasting, lectures and codes. And if you go to module 2, here's the PDF that I'm just walking you through. And there's this Python notebook that we're going to go over in the next part. So let's go back to the PDF. All right, so yeah, this is module 2, setting up the deep forecasting environment. These are the course prereqs. And I expect you to either be familiar with these concepts, or you have already taken these courses before, or you have watched my videos. So Python crash course, I think it's about 3 hours, me doing some basic Python operation. And if you're quite familiar with Python, you can go ahead and skip this one, but I expect you to know the very last one. This is what I expect you to know. Python crash course part 9. Which is about time series. So I expect you to be able to handle, time series data, how we change the index, make it to time series, and etc., right? So this is what I expect you to know. Another thing, which is a prereq for the course, is let me actually open all of them. So this PDF is clickable. If you can click on these links, and so here's another playlist. Basically, if you want to run things locally on your local machine, I highly encourage you to use vscode as your code editor. This is one of the most popular code editors now, and it is really it's worth your time and effort to learn it and put it and make it in your arsenal. So this is again another crash course. The third prereq is, again, if you want to do things in Google Colab, if you don't want to run things locally and you just need a browser, so simply you can set up the Google Colab, and then all you need is an internet browser and a Google account. So if you're curious what are some tricks when it comes to Google Colabs, make sure you check out this playlist. And then finally, Pycaret. So this is going to play an important role in our course, especially for the first half of the course that we cover some classical econometric models and as well as machine learning models. So again, here's another short playlist for you. And if you're not familiar with Pycaret, how to install it, what is it, and you're going to do some basic regression and stuff here. This is in this playlist. And don't worry about this last one, predicting stock prices and etc. So these are the ones that I'm going to cover in very details in this course. And so maybe you can skip, just watch the first 3 of them to familiarize yourself with the concept of Pycaret and what it is. All right, so those are the prereqs for the course. And make sure that either you're familiar with these concepts or you have watched the videos. All right, and so if you're running things locally, I highly encourage you to install a fresh Anaconda on your local computer. Anaconda is a distribution of Python language, and the reason that we're going to use it because it simplifies package management through creating these conda, we call it environments, right? So we're going to create an environment for this course. We can call it, for example, deep forecasting, and we install all the packages that we need in that environment. And this helps us to keep this environment separate from any other projects or tasks that we're doing on our local computer, right? Down the road, it's going to help us make sure that our code is reproducible. There is no package version conflict and things like that. So again, here's how you can install it. You click on this, and then depending on if you go to free download, you can skip registration. Depending on if you're on Windows or Mac or Linux, feel free to click on these things and then just move forward. The latest version is 3.11, Python 3.11, and this is what we're going to use for the course when we're setting up our Pycaret environment as well. So And we're going to use Jupyter Notebook. And basically, Jupyter is a web-based interactive development environment for notebooks, codes, and data. So the cool thing about Jupyter is that, if I've taken any of my courses before, you see me coding, and then there's some narration, text in this, explaining the codes and things like that. We can do some visualization. So this is a very cool interactive environment, and I would love to use that one. But however, we're not going to use Jupyter Lab directly. We're going to use it through VSCode editor. So as I said earlier, this is the most popular source code editor as of today, and I highly encourage you to learn it. No matter what you do, where you go, you will find yourself coding in the VS Code. This is a very powerful code editor because of all the extensions that you can add and all the cool capabilities. For example, if you have a GitHub Copilot, you can add it and it can help you to code on the fly. So this is very useful actually, and we're going to use this for the course. So you will see me coding and using GitHub Copilot along the way, and or you can use ChatGPT or any other LLMs which is out there. I think these things are getting better and better these days, and the coding is going to completely change. The way that we code is going to completely change. I think we should focus more on the theory of these concepts and get help from, let's say, large language models when we are writing codes from scratch. All right, so again, here's a link if you want to install VS Code. And so basically, this is if you want to run code locally on your computer. You need a combination of VS Code, Notebook, and Anaconda. If you don't want to run things locally and all you have is an internet browser and a Google account, you can still do everything we do in this course. Actually, the notebook that I provide, there's a link at the top of each of them. If you click on them, you can directly run the code in a Google Colab notebook. So if you just want to tip your toes, you don't want to install these things on your local computer, go ahead and use Google Colab. And basically, Colab is a Jupyter Notebook style environment that runs entirely in the cloud. And the good thing is that it doesn't require any setup, right? And you can also use some compute power, hardware like GPU and TPU as well, even in the free tier. So this is very cool. There are some limitations. We're going to talk about the limitations briefly, but for this course, because of the data sets are pretty small, we don't need huge compute power. Maybe for the deep learning section of the course, the GPUs that Google Colab offer is good enough, so you don't need to be worried about anything. All right, so again, here's the link for Google Colab. Just give it a try. And also, you can definitely check out this. Where is this? Yeah, this short playlist that I have for Google Colab. All right, going back to the slides. The packages. So remember, guys, we're doing three kind of modeling, right? We are doing classical time series modeling, which is a statistical learning, let's say. We are doing machine learning, and we are doing deep learning. For the machine learning, we are going to use ScikitLearn. So this is, I think that this is the most widely used package when it comes to machine learning modeling. The time series version of Scikit-Learn is SkTime, and we can do SkTime, but in this course I'm doing Pycaret. So Pycaret is the library that for the machine learning models that it has, it's basically using Scikit-Learn behind the scene. All right, so this is the Scikit-Learn, and then this for the machine learning section of the course and our classical models like ARIMA, ETS, and these models, we are going to do Pycaret. Pycaret is an open source, low code machine/statistical learning library. This is in Python. Basically, it's a Python wrapper, and which automates machine learning workflows, right? So it's a wrapper around several machine learning and statistical learning packages. So for example, ScikitLearn is here in a statistical. Statsmodel is also one of the packages that Pycaret is using. Many packages. I think it comes with 40 plus, 50 plus packages. We can look at the list of all those packages, but the cool thing is that you just need to pip install, let's say, Pycaret, and then be done with it. At least be done for the statistical learning and the machine learning part of the course, right? So here's the link to Pycaret. And so depending on when you're watching this video, this is the latest way to install Pycaret. Simply, you have to create your own environments, and I'm going to show it quickly to you how you do that. Again, the reason, if you want to run things locally, if you want to run things on Google Colab, you just do pip install Pycaret at the top of the Google Colab, and that's it. All right, so yeah, the reason that we are going to run things in the environment is that Pycaret is a kind of bulky package. It has so many dependencies, and we don't want to mess our base environment when we're coding. So, and for this course, we're going to use the full version of that. So if you scroll down, let me see, there you go. So you have to do pip install Pycaret bracket full, and this is going to install the full version of Pycaret on your computer. Okay. And once you have set up your Pycaret environment, and then the rest is pretty straightforward. So if you haven't worked with Pycaret before, you'll really like it because it's super easy to use, to work with, and you realize that your job is to understand the theory behind the models or how Pycaret is working, not basically how to do it in Pycaret. So once it's set up, literally it's 4 lines of code or maybe 5. So you have to say from Pycaret.timeseries import everything. You need to create an environment or experiment. So you say, you can call it anything. Experiment is a time series forecasting experiment. And then you need to set up that experiment. You need to pass a data frame. So this data frame, we need to make sure that the indices are the date time and compatible with Pycaret package. I'll walk you through in the Python part for this module. And you need to say, okay, here's my target variable. For example, we have airline passenger data. The target is passengers. How many forecasting horizon you have in mind? What is your confidence intervals? Let's say coverage is 95%. And then this is one line. You can say compare models. And here's a list of models available in Pycaret time series as of now, if you install the full version. So if you install the full version, here's a list of all the models available. And we're going to cover almost all of them during the course, the theory of it. And with that, then the next time when you run things in Pycaret, you feel confident that, okay, I know the theory behind these models. It's not just blindly doing one line of code and compare and see which model is performing best, right? So that's that thing, everybody can do that, but your job is to make sure you understand what is the difference between all these models. So the cool thing with Pycaret is that it comes with some benchmarks. Remember in the previous module, we talked about 4 benchmarks that we discussed, like naive forecaster, the average, seasonal naive, and the other one was drift, which is not one of the benchmarks in Pycaret, right? Yeah, these are, we're going to cover all of these things: ARIMA, auto-ARIMA, exponential smoothing method, ETS models. We're going to talk about why one of them is method, why one of them is model, and etc. These things like that. And when it comes to the machine learning part, so these are the machine learning, let's see. Okay, let's see, why is it confusing? Anyways, so these are the machine learning models available in Pycaret, right? A linear regression, elastic net, ridge, lasso, you name it, right? KNN, random forest, XGBoost, light GBM, and cat boost. I think the very last one is cat boost. Yeah, cat boost. And if you pay attention, the ID of the models in Pycaret is something like this: CDS DT. So these are conditionally deseasonalized and detrended data. We're going to talk in very details what does this mean, and because it's using ScikitLearn behind the scene, and we know that we cannot. This is time series data; they are not independent, and so the observations are not ID. You cannot simply shuffle the data. So in order to make sure that now we are doing it less wrong, if you do it blindly in ScikitLearn, we have to make sure we are deseasonalizing the data, the detrending the data. Again, I'm going to cover all these things in the machine learning section of the course. and tell you why we need to do things like this, and what are the wrong ways of doing time series analysis using ScikitLearn. And by the way, we're gonna do machine learning modeling both from scratch in ScikitLearn and automated version using Pycaret. So you will learn both of them, and you should be able to compare your ScikitLearn models with Pycaret. They should compare similarly. They should perform similarly. All right. And for the deep learning section of the course, we're going to use Keras, and I think everybody is familiar with Keras if you have taken any kind of deep forecasting, deep learning courses. Keras is a high-level open-source neural net library written in Python, and basically it was developed to make it easier for researchers and developers to build and experiment with deep learning models, right? And so again, this is an example of, for example, computer vision using CNN. By the way, we're going to use CNN for time series forecasting as well, right? So yeah, this is a sequential data. We talk about all the details of these things in the course. All right, so to put it all together, so we're going to use these packages throughout the semester. Some data wrangling and visualization like Panda, NumPy, Matplotlib, and Seaborn. Our machine learning libraries, ScikitLearn, XGBoost, LightGBM, Pycaret, SkTime, and we're going to do Profit as well, because the very last module of the course is Profit and Neural Profit. So we are going to introduce that package as well. And yeah, for the deep learning, we're going to do Keras. Okay. So in terms of what is the difference between if you want to run things locally in your computer or if you want to run it in the cloud, right? So this is basically, I think it's pretty straightforward to everybody. So you can pause this video and look at the pros and cons. But in a nutshell, workstations, it's more flexible. The fixed cost is higher, of course, but it's more flexible. You can be offline. It's if you're working with sensitive data, you don't need to be worried about security, things like that. But the cost is the scalability, right? And especially these days with the advancements of technology, it's hard to keep up with the latest hardware unless you're willing to pay a ton of money, right? So again, maintenance is going to be costly. For cloud computing, cloud platforms, we have GCP, Amazon AWS, and Microsoft Azure. So the advantages are it's powerful computing resources, they're scalable, easy to use. They can be cost effective, pay as you go, but at the same time, it can become expensive if you have a large scale experiment, right? So, and this dependency on the provider, obviously, you will be dependent on Amazon, Google, and Microsoft if you want to deploy your model in these let's say platforms. Obviously you have limited controls over the hardware, but there are tons of features available that you can mix and match, and maybe one of the fewer downsides is just security and internet connection. But again, these days, depending on what part of the world you live in, this can be something important or less important. All right, and we are going to do Google Colab, right? So we don't need to do cloud computing. We're going to do using Google Collaboratory. And do not confuse these two concepts. Yes, GCP and Google Colab are both provided with Google, but Google Colab is basically designed for education, research, experimentation with machine learning and data analysis. And it has a free version, and the free tier, it's just like a browser-based Jupyter notebook environment, right? On the other hand, cloud platforms, these are comprehensive suite of cloud computing services for building, deploying, and scaling applications and infrastructure. So what we need is basically a simple internet and a browser, and then I don't know what's wrong with my PDF here, and then just run things in Google Colab. Or we can run things locally on your computer. However, when it comes to the deep learning section of the course, most probably many of you guys are going to switch over to Google Colab unless you have GPUs on your computer. Okay. All right, now let's quickly discuss why we do what we do and why we're using these packages and these platforms. So if you're not familiar with Kaggle survey, so the latest version which is out is 2022. And basically, Kaggle runs a survey among machine learning and data science practitioners, around the world. And this survey is one of the most reliable sources about the state of the industry, right? So what packages are being used, what editor, what languages, and et cetera, et cetera. And you can look at, if you click on this kaggle.com, this link, it's going to show you a detailed PDF of all the statistics that you may want to check it out for yourself. But in a nutshell, it's something like this. Again, why we are doing what we're doing, right? So the most popular programming languages as of 2022, I bet it's still the case in 2024. It's Python, so that's why we're doing it in Python. We could do time series forecasting in R as well, but again, because we want to make sure that this is the most widely used platform, we are going to do Python. And then in terms of IDE, look at the first two, Jupyter Notebook and VS Code. These are the most popular IDEs back in 2022. We're doing a combination, right? We're writing notebooks inside VS Code. So basically, we're doing the top two most popular IDEs. And here is another reason probably why we should switch over to VS Code versus RStudio, right? I myself started my journey in machine learning and econ and modeling and things like that in R. But as you can see, from 2018 to 2022, RStudio is becoming less and less popular. And on the other hand, VS Code is becoming more and more popular. So that's why I prefer you maybe learn the time series concepts in Python using VS Code. Having said that, I would say down the road in the next couple of years, this is going to be less of an issue, because the chatbots like ChatGPT, Gemini or Claude 3 or whatever, they're going to help us code in any language. It really doesn't matter. So maybe the biggest takeaway for you is that learn the theory of these concepts more compared to how to apply it. You will be able to learn how to apply it very fast with your AI assistant. All right. And these are the Python packages for time series analysis out there. It's not limited to these ones, but these are the more popular ones. And this is a table that I personally put together based on my experience working with these packages. So if you see more ticks, it means that it's morely focused on this, right? So I'm breaking down these packages into if they cover the metrics, classical econometric models for time series forecasting, machine learning, or deep learning. So Statsmodel is heavily focusing on basically statistics and econometrics. So models like ETS, ARIMA, and these models are basically written in Statsmodel, and we're going to use the. And by the way, any other models that is, for example, Pycaret that is using it's basically providing you with those models. It's a wrapper on top of Statsmodel. So Pycaret, for example, is a combination of Statsmodel, ScikitLearn, and some lower, less automated packages, right? So this is Statsmodel. The next one is ScikitLearn. ScikitLearn, obviously, it has linear regression, so that's why I put a tick here if you want to consider linear regression as an econometric model. And it's mostly machine learning models. Then Keras is mostly focusing on deep learning model. And then Pycaret is a good combination of both econometrics and machine learning, but provides zero deep learning. So that's why in this course, we're doing a combination of Pycaret and Keras to cover everything. And there are some packages that try to cover all the available time series models, including econometric, machine learning, deep learning. And those packages are Darts, GluonTS, and NixTLA, right? So Darts is focusing on advanced time series and forecasting. I would say machine learning side is not that, at least as of now, or as far as I know. It's not as powerful as Pycaret, so that's why I prefer to still prefer to work with Pycaret for the course. GluonTS, this is very good in terms of basically if you want to do probabilistic modeling or if you need larger scale models, but that's not what we're going to do in this course, so I'm not going to use that. And the last one, NixTLA, this is something that I'm going to do some miscellaneous topics by the end of this course or maybe later, and talk about some of the features of NixTLA, because this is a package which is becoming very popular and it covers everything in just one package, right? And if you want to do, for example, using state-of-the-art transformer version of time series models, NixTLA has it. If you want to do, for example, confidence interval versus conformal predictions, NixTLA offers something, right? So again, maybe later on, I'm going to cover some miscellaneous videos, basically working with NixTLA. But for this course, we are focusing on these two packages, Keras and Pycaret. All right. Now, in the next part, I will be talking about basically doing some simple time series operations in Python. Until the next one, take care. If you're looking to stay updated with the latest versions of the course's materials, please make sure to follow my GitHub and remember to refresh your repositories periodically. If you find yourself needing a bit more background in econometrics, machine learning, or deep learning, check out my other YouTube videos for additional insights. And for all the latest news and quick updates, don't forget to follow me on Twitter. Thanks for joining me, and let's keep learning together.